In this problem, we will set up an integral that represents the length of the curve. Then, we will use our calculator to find the length correct to 4 decimal places. Our curve is y squared equals natural log x for y values between -1 and 1. Our formula for arc length is the integral from a to b of the square root of 1 plus dy dx squared dx. There are a couple issues with this formula for this particular problem. Because of the way our equation is written, it's not completely straightforward to find dy dx. Furthermore, the a and b in this expression are x values that bound the arc that we are talking about, but we do not know those x values. Therefore, for this problem, I think it will be easier to do in terms of y. So an easier expression will be that the length is the integral from c to d of the square root of 1 plus dx dy squared dy. The c and d are y values, and we know the y values go from -1 to +1. So all that remains is to find the derivative dx dy. In order to do this, it is most convenient to take our equation y squared equals natural log x and switch it to exponential form. So x equals e to the y squared power. Then we can take the derivative of x with respect to y using the chain rule. We get e to the y squared, multiplying by the derivative of the inside, we multiply by 2y. So our derivative, dx dy squared, is equal to the expression 2y e to the y squared squared, which is 4y squared e to the 2y squared, remembering that we multiply the exponents. Now our expression for the arc length becomes the integral from -1 to +1 of the square root of 1 plus 4y squared e to the 2y squared dy. Using our calculator to evaluate this, we get approximately 4.2552. Now, in case it helps, what I'm going to do is go over how we plug this into our calculator to get that value. To type this in our calculator, we'll go to Math and choose number 9 for FNINT. Then we will type in the function, which is the square root of 1 plus 4. Okay, now we have y, but I find it easier just to use x. So 4x squared e to the 2x squared. Then we're going to put a comma, then the variable, which is x in the calculator, even though it's y on our paper, and then the lower bound, which is -1, and then the upper bound. So we have 4 arguments. We have the function itself, we have the variable, the lower bound, and the upper bound. And then we get our final value. If you're lucky, your calculator may show you something a bit more intuitive. If you go to Math and you choose number 9 for FNINT, you'll get this, and then you can just type it in exactly the way you think you should. I am still going to use x instead of y, just to make it easier to type. And again, we get our final answer.